Good morning, everyone. Thanks for taking the time to join this session. My name is Phil Harrison. I'm a solution architect with Amazon Web Services, and I'm based in Sydney, Australia. The session topic today is serverless linear playout, i.e. building linear channels in the cloud. But I want to take a bit of time just to sort of set the scene a little bit. We're going to be talking about some theoretical stuff, talking a little bit about experimentation and innovation. So I don't know how many of you are familiar with AWS as a platform, but I checked this morning and we have 166 services available. Just curious, has anyone logged into the AWS console that's here in the crowd? Okay, cool. Yeah, that's a good percentage. Good stuff. But you'll be glad to know that I'm actually not here to talk about any of those services. What I am here to talk about is experimenting, right? And the reason we have 166 services isn't to generate new ways of selling you the same thing. It's essentially to give you as many different types of building blocks so that you can quickly iterate over ideas you have and build something hopefully that's new and innovative in whatever industry you partake in. So I took that line of thought and decided, let's build something interesting and cool in my first year as a solution architect at AWS. And the idea I had actually came from this episode of Rick and Morty. I don't know if anyone here is a Rick and Morty fan. Maybe your kids are, maybe it just shows how immature I am to still be watching this show, but it is a great show. And in this episode, Rick essentially creates a set-top box that gets access to TV channels from not only every single cable provider in this universe, but every single cable provider in the entire multiverse. So we're talking literally billions upon billions of TV channels. And that got me thinking about the costs associated with delivering linear television, especially if that linear channel is just thematic. It's just basically pre-shot, pre-canned programming that's put on a schedule and then played out to consumers increasingly over the internet. And then I wanted to sort of confirm my own internal bias that people do still watch linear television. They still enjoy a linear experience. And this is some research done by Channel 10 in Australia. They're owned by CBS here in the States. And essentially, they segmented their audiences into 4 different buckets. And we have the cord forevers, which are generally people that are a bit older and continue to watch their linear television through a set-top box and a cable provider. Cord shavers, who simply watch SVOD and BVOD services through that set-top box. Sort of, you get your cable set-top box and you get Netflix through that as well, so it's sort of a hybrid mix. Cord cutters, obviously we're very familiar with that term, people that have cut back on their cable set-top box and using over-the-top services almost exclusively. And then cord nevers, so these are the younger kids that have grown up with Twitch and YouTube and don't really understand what television is in the traditional sense at all. But the key takeaway is that whatever segment you're in, TV, as in linear experience television, is still in the top 2 experiences across all segments. So that to me shows that there is still quite a large appetite both now and into the future for linear experiences when you're watching TV. That is also further sort of proved by this app in Australia, where I'm from, and it is essentially an Apple TV app or an Android TV app that mimics an EPG, which I find is quite fascinating because it's almost taking a step backwards and saying, let's bring back something that we're all used to, and that is an electronic program guide, when in fact every single one of those shows that you see available there are available as catch-up. So there's no reason somebody couldn't go in and watch Home and Away, which was actually just finished airing. But what ends up being the case, at least to all of these commercial broadcasters that I've spoken to, they see more usage on the live stream, as in the linear live stream of their programming, than they do on the catch-up. even though it's a better experience in the catch-up, they can watch it in high quality, they can watch it when they want, and it's simply because the experience of watching TV to them, in many cases, is just sitting down and watching whatever is on. So let's say we wanted to do something like this exclusively in the cloud. Let's say we wanted to go from one linear TV channel to hundreds. There is a lot of complexity in Playout and sort of head-end broadcast infrastructure. This is a slide that you're not supposed to understand. The idea is that it is so complex and convoluted that your mind just goes basically, wow, how does this even work? But this is very common, especially for broadcasters that do channel origination globally or throughout Europe in this case, which is an entire continent with different countries and different satellite DTH providers. So if you wanted to make a TV channel in the cloud, the easiest way, at least logically, is to take the architecture that exists right now on many premises and shift that into the cloud. And that will immediately bring with it cost savings, agility, and the ability to expand very quickly into new regions and also downsize and upsize your capacity when needed. But you can see here, I've overlaid the AWS services that would go into the mix, but when you see those little icons that look like computer chips, those are essentially partner services that you would get on the AWS partner store or things that you would bring yourself, okay? So what I'm trying to say here is that it isn't a complete end-to-end solution that you can go to AWS and just buy out of the box. What you'd do is you'd put together a few different services and make that into a complete architecture from beginning to end. But I wanted to take this a step further and really think about what is a channel and what is a channel in the cloud. And it is really just a series of VOD clips, right? And this concept of taking something that is already pre-canned and transforming it into a live stream, i.e. VOD to live, isn't something that's really that new. I've seen it done a few times. But what I wanted to do is really break it down into the most simple essence. And what that is a playlist describing media segments. And you can generate that playlist any way you want. It doesn't have to be done by the encoder. It doesn't have to be done by the playlist generator from the packaging system. It can be done completely out of band, and however you want to generate that playlist is up to you. So it got me thinking, is it possible to reuse SVOD library, let's say, or an AVOD library, or any type of VOD library that's sitting inside S3 and repurpose that to create a live linear channel, okay? And I got started how most developers do, most programmers, they start off by Googling things and checking if there is anything out there that already does it, usually by searching on GitHub, and there wasn't. So I thought, well, this is actually a great experiment that I could run on top of the AWS platform and see if it works very quickly, right? So this is something that I did in my spare time. This is something that took me about an hour to validate whether or not it was possible, and then I iterated from there. So once I'd already decided or made that evaluation that it is in fact theoretically and technically possible, I set up some goals. And what I wanted to do was simulate the exact characteristics of a linear OTT stream, including ads. And I'll explain why ads are important a bit later on. I also knew that we needed to build a scheduling interface. A linear TV channel doesn't make any sense unless you can schedule what comes after what in sort of a linear playout fashion. I also wanted to achieve Netflix video. I mean, I'm just using Netflix as a bar in terms of how great their video quality is, but you can substitute any sort of high-end SVOD service in there. Essentially, I'm saying I want VOD quality in a live stream, which typically is not the case. I wanted to decouple encoding from Playout. And this is really the crux of the whole solution, in that you encode all of your assets one time and then play them out as many times as you put into the schedule without ever having to re-encode it. I also wanted to decouple the concept of latency from the forward buffer. If you remember the very first presentation yesterday about industrializing OTT experiences, one of the biggest contributors to a latency on an OTT experience is the fact that the client generally is buffering multiple seconds of video. And usually it's equivalent to 3 segments of the playlist, at least in the HLS and Apple case. But if I know the schedule ahead of time, I can basically, in the playlist, make the segments future looking. So I can make the playlist go into the future by 3 segments, therefore making it 0 latency relative to my schedule, but still have a very healthy forward buffer. I also wanted to ensure that I was reusing a cache as much as possible. So if somebody had watched a title in an SVOD or an AVOD or a catch-up experience, I wanted to reuse that segment in the CDN, because that means that that CDN doesn't have to go back to origin to serve the same content, increasing performance, decreasing costs, all of that good stuff. And finally, entirely serverless and automated. And I'll go into a little bit of detail around how I achieve that. And that's important because you're defining your infrastructure as a piece of code. One single text file describes 20 or 30 different components that all talk to each other without ever having to physically think about a physical device. And of course, that means I can spin it up in any region on the AWS cloud, in any part of the world. I can also turn it off completely when I don't need to use it, and I can scale it up and down very rapidly. So now I'm going to tempt the demo gods, as they say, and actually try to give you a little live demo of what this looks like. So I will get out of this, and I should be able to make sure my internet is still working. Okay, I think we're good here. So what you're looking at is a simple scheduling interface that I built. And if you remember, this is one of the goals. And this is just an off-the-shelf front-end GUI that you can build very easily using AWS Amplify. And I'm going to go ahead and create a channel, okay? And the channel number is sort of an analog to what you used to do on a cable set-top box. You would dial in a channel number, but really it can be any number you want. This is just a kind of a unique ID that happens to be a number. And then I can put in here a channel name, but this could be anything. This could be like variety or say documentaries, whatever you want it to be. The track config down there describes the characteristics of your existing encodes. So if you have an S3 bucket that has potentially hundreds of SVOD assets or AVOD assets, something like that, generally they fit under the same sort of conform. They usually have 2, 3, 4, 5 video bit rates, maybe 1 or 2 audio bit rates, but they're all roughly the same. So you need to define that ahead of time, because the player needs to be able to transition from one asset to the next asset within the same bitrate representation without it needing to reinitialize the decoder. So we need to define what each individual asset looks like ahead of time. The CDN, you can plug in your own CDN as long as it is configured to point to the correct S3 bucket. In this case, we're using CloudFront. And then I can go ahead and create the channel. So now I've created this channel 987646. It has nothing scheduled, so you can see the schedule is empty. But what I'm going to do is I'm going to go and create an automatic schedule starting 15 minutes in the past and schedule it for 60 minutes. And this should populate the schedule with some content, and I'm going to explain a little bit about what's going on in this interface. So as you can see here, there's the first episode in my, or the first title in my schedule is Grand Tour Episode 1. It's a 30-minute clip. And the blue bar denotes how far along I am in that asset. And the light blue denotes the forward buffer. So you can see here, the playlist tells the client this amount of content should be downloaded into your forward buffer, but start playback basically a minute in the past. But that minute in the past corresponds to now, because the latest segment in the playlist is actually a minute in the future. And you can see here that basically, because I'm now playing this asset, I can't make any more changes to this clip because it's basically being played out, so it's locked. But if I go ahead down to the second clip here, I can define the length of the ad opportunities. So usually in an AVOD type setup, you would have your clip stored in S3 with markers inside the playlist to tell a downstream ad server, this is where you insert ads, okay? But in a VOD experience, you don't define the length of that ad break because it depends on how you've interacted with the ad server in terms of how many ads you're putting in the pod and the ad fill rate, etc. But here, because we're defining a linear schedule, we need to know exactly how long each ad break is. So this is what you can do here. You can change the ad breaks to be different durations. In the auto scheduler, it's just set to 30 seconds. Now, if I click watch, this should bring up a page with a player that's playing back the stream. And we've happened to come in at a time when there is an ad. And I'll let everyone go back to the main screen and click play for themselves. Yeah, and if you have an iPhone, you can actually click, or you can bring up your camera app and scan that QR code, and it'll bring up the HLS playlist of this episode that's currently being played out, okay? The other thing you'll note is that the bit rates are constantly changing, and that's because the playlist, or at least the master playlist in this case, has got, I think, 12 or 13 representations included in that playlist. So depending on the network conditions at the time, it will go up and down the bit rate ladder as needed. One thing I would call out, though, is one of the goals, if you remember earlier, was to make the video quality as good as a VOD experience. And the way that's possible is because I have as much time as I want ahead of the playout to encode that asset. So I can encode it, in this case, with 2-pass encoding, as well as quality-defined metrics, so that the bits are used at different points in the video stream depending on the complexity. What's more is that as long as I have 800 kilobits of bandwidth available to me, I can, averaged over 1 minute, I can watch this stream. But in reality, right now, the bits being used will be much lower than 800 because there's not much complexity going on. But when they cut to a promo where there's a huge explosion, that may end up being 1.5, 2.5, 4, 5, 6 megabits per second for a very, very short period of time. And because modern devices, the decoding forward buffer, at least the hypothetical model in the decoder, it is able to burst up and down bit rate quite significantly. And this is used extensively in the VOD world, but now we can leverage that sort of efficiency gain in the live world as well. Did anyone manage to scan it? Did it work? Or it worked? Cool, and you can see there the commercial break is essentially a slate, and that slate will go as long as you define in the schedule, but the intent is that you would layer in a downstream server-side ad replacement tool, something like MediaTailor or Google DFP, and that would substitute the slate with an ad that's contextual to that user, as in every user could get a different ad if they wanted to. And I think if I go full screen here, you should see it jump up to a much higher bit rate, but unfortunately it's quite a boring part of the schedule where they're talking about this really boring car. But you can see there it just jumped up to 4.2 megabits. And 4.2 megabits in HEVC world is actually extremely high quality. In AVC land or H.264, that would equate to maybe a 720p experience. This is actually a 1080p stream that's at least visually lossless from the source file, which is an MXF ProRes 422 sort of mezzanine asset. I'm hoping they'll cut to an explosion. If not, I'll move on. Here we go. So this, in a live stream, wouldn't have sufficient bits to look as fantastical as this does right now. But because we're reusing the VOD clip that was pre-encoded, no, ad break at the wrong time. Yeah, it depends on your device resolution. If your device resolution isn't scaling up, then it won't. It's also dependent on the Wi-Fi. If the Wi-Fi doesn't allow you to go to that higher quality, it won't. Yeah, the quality should be almost imperceivable to watching it on a Blu-ray, let's say something like that, because a Blu-ray disc essentially overestimates the bandwidth enormously. It has like 50 megabits a second, something like that. But the quality, at least perceived, should be equivalent to watching this at home on a Blu-ray. And scenes like this, where you have very, very fast motion, stuff like that would macro block very, very quickly if it was set to 4.5 megabits as a static bit rate rather than an average over a minute. So I think we've seen enough of the grand tour. What I will go back to is back to the presentation and talk about a real life use case. Well, actually, what I might first do, I was debating whether or not to add this slide in there, but I just wanted to add some numbers in terms of how much this cost to run the demo. So if I had 100 unique 40-minute shows that were being played out, and each one of those shows was used 100 times in that month, so your schedule sort of repeated programming somewhat, and I had 6 H.264 bit rates, 1 AAC audio bit rate, which is fairly common to have that sort of setup. These would be your indicative costs. You would have to store those assets in S3. That would cost roughly $1. You'd have to generate the playlists, which are then cached by the CDN. That would cost roughly $1. You would have to convert all of those assets into the multi-bit rate representations. That's your biggest cost by far, right? And if you're reusing the content, you don't pay that incrementally. So once you've paid it, you pay it once, and then you can deliver it as many times as you like after that. You would have to store the schedule and all of the asset metadata. So the playlist generator knows where all the segments are in the file. And then you'd need to invoke API gateway as sort of a front end to Lambda executions. Both of those things would roughly cost you $1 each. So total cost to run a channel with 100 assets, including the encoding, would be around, as you can see there, $16, $17, $18 a month per channel. Okay, obviously that doesn't include CDN costs or delivery costs. That would be in addition. That's 264, but in the next slide, something is just lessons learned in case you're thinking of doing something like this yourself. Inside the HLS playlist, there's a concept of a discontinuity media sequence ID and a media sequence ID. This is of paramount importance. So every single time a rolling window playlist, one of the top segments goes off the list, you must increment that media sequence ID so that the HLS decoder knows that this is a new playlist, not an update of the previous one. And every time you increase that number, if you look inside the console of your HLS player, you'll see it starts a new render chain, right? So it's very, very important that the player knows about the media sequence ID, and this is consistent. You can't skip numbers. You can't forget to increase them, otherwise the playback will stall. The next point here is around using HEVC as a codec. So during my experiments, the Grand Tour title that you saw there was HEVC encoded plus quality-defined bit rates and 2-pass encoding, right? So that resulted in roughly a 50% bit rate saving, but it was 10 times the cost of doing the same thing with H.264, 1 pass without QVBR. QVBR is actually free. There's no incremental cost of you using QVBR, so I definitely recommend using that in any case. But 2 passes are quite expensive, and HEVC, for the licensing reasons and things like that, ends up being about 10 times the cost. But it's actually worth it in a lot of cases. Because you're encoding once and reusing many times, you're amortizing that 10x cost over a much longer period, and it ends up paying for itself given a long enough time horizon. So if you do your calculations and you say, right, I've got 500 assets that need to be encoded this month, but I'm going to play them out for the next rights window over the next 6 months, every time that gets played back, your 50% bitrate saving adds up. It adds up on CDN usage, which can, in a lot of cases, cover the 10x in cost, not to mention that your users will have a much better quality experience for the same bitrate. A few other things to do with AWS is inside Lambda, there is a small instance store. So if you're making constant calls to a database to pull a schedule, you want to use that as much as possible, because if you have lots of users requesting a playlist, even though it's cached by the CDN, they still need to get an update every segment duration, and you want the Lambda instance, when it runs, to remember basically the database call that it did before. Inside DynamoDB, if you are storing large text, i.e. a playlist file describing every single segment in that video track, gzip it. You can gzip things inside DynamoDB and then un-gzip them inside Lambda. That ends up being a lot faster. And use CloudFormation for everything all the time. So if I was developing something new off the bat, even though I'm purely experimenting and there is really no intent for this to become anything production worthy, I still use CloudFormation because it allows me to develop much faster, deploy changes, keep track of things, and it's just a better tool in all cases. When you get to the production sense, you can implement a DevOps type pipeline, and then having everything defined as code will pay enormous dividends as you have to maintain this over its lifespan. So, a real life use case for one of our customers. Seven is a commercial broadcaster in Australia, and I got their permission to talk a little bit about how they have used this inside their apps. So at the moment, they have a VOD catalog on these devices here. So they have smart TVs, gaming consoles, web, and phones. And they had two split architectures, one for live, one for VOD. So they were duplicating encode, duplicating packaging. Basically, that EPG guide that you saw earlier on the presentation was driven out of an entirely different system. But what they found was that they could actually reuse the VOD libraries and publish that via relinear and create a linear live stream. So they built a wrapper around it, an API call to create a channel, an API call to select content to schedule. So the front end that I showed earlier, you could interact with an API call. And the reason they did this is it's simple, it's repeatable, and it's relatively cheap, as we found out a little bit earlier. So what is possible? Given that we now have basically an unlimited matrix of channel numbers to content mapping, we can go crazy with the types of live channels that exist. So the content team came up with small social media campaigns that basically said, on Friday night, it's going to be ladies' night. We're going to put up a live stream that only lasts 6, 7, 8 hours, a pop-up channel, so to speak. And on that, we're going to promote what's on, and we're going to start a hashtag trend, and everyone's going to have this shared experience of watching this type of themed content, which is basically all content that they've scheduled themselves there. And then another one for Bride and Prejudice, which is just basically a binge session of that show, as well as other content that's completely live. Oh, sorry, that is a VOD, but represented as live. Why they did it, live audiences watch for longer sessions than VOD. So what that means is that you can insert more ads. You can basically get more impressions, and people generally watch for multiple hours when it's live, rather than one episode at a time in VOD. As we mentioned, yeah, it's cheap. The only real costs are generating text files. So you can imagine that just from a compute standpoint, generating text files is a lot less computationally intensive than re-encoding video assets over and over and over again. Channels will target key demographic audiences, so they can start to address their audience in a much more discrete way. So they can say, right, we're going after females from the age of 18 to 40. These are the postcodes that are most likely to watch it. We can target that as well. They can also give exposure to back catalog programs to audience. So they have, I believe, hundreds of hours of a sort of a soap opera show that is basically only made because they sell it internationally. But the content exists inside their back catalog that no one may ever see if they had to search through multiple pages of a VOD interface. So they can surface that as a live stream, and they can also monetize that through advertising and saying, we have this show, it has a lot of beaches, has a lot of product placement opportunities, a lot of addressable advertising. In that sense, revenue streams, so they have the SCUDdy markers. They're not actually really SCUDdy markers, they're essentially tags inside playlists, but you can still do the server-side ad insertion as if it was live. Yeah, so as I mentioned, this is one of the home pages of the interface, and down the bottom there, the live channel from this sort of serverless playout is sat right in amongst the existing playout, which is basically a repeat of their traditional broadcast. So it really does, to the user, look exactly the same as broadcast television. It's just developed through an entirely different back-end architecture. And so what this leads to is the eventual state of hyper-personalization. Because the number of channels you can have is theoretically unlimited, you could have a different channel number for every single one of your users. So just imagine a user ID is equivalent to a channel number, and then you can end up with a relinear channel per person that is essentially recommended VOD programming, recommended live. You can continue watching, you can skip latest VOD episodes, and you can add programs that happen to be on to a watch list to then later watch them down the line. You could also develop an Alexa skill that basically says, please play a live stream, and that small demo I did earlier would be executed automatically, and some content could be automatically scheduled in a live transmission, starting from the point at that person invoked that Alexa skill, and then they could watch 5, 6, 7 hours of programming right then, right there. So I've got roughly 5 or 6 minutes left. I just wanted to do a quick architecture diagram so that people that are a little bit more familiar with AWS can understand a little bit how it's put together. So on the media preparation side, if you needed to re-encode your assets, you would run it through media convert. And then on the output S3 bucket, a small parse playlist Lambda function will execute on any new files that are in there. But if you already had that VOD file defined, you could simply run the playlist files, as in the HLS files, through this parse playlist Lambda script, and the result will be the same. So you don't necessarily need to re-encode files to add them to your scheduler. And then that parse playlist Lambda function would essentially store all of the segment attributes of those video and audio tracks inside a DynamoDB table. On the media delivery side, sorry, I'm just going to build this out. On the media delivery side, this is really where the scheduling interface would be defined, and then the user, when they make a request for a playlist, executes a Lambda function to generate a playlist. So the user would come in via a CDN. That CDN would, based on the rules, make a request to an API gateway instance, and then that API gateway instance is configured to recognize whether or not it's a master playlist request or a child playlist request. If it's a master playlist request, it looks up the channels table and basically returns all of the different tracks available in that channel. And then once it's a child playlist request, the Lambda script will look up inside the schedule table, figure out which piece of content is actually being played out and how far into that piece of content the current schedule is, and then in the assets table, look up which segment to insert into that playlist at what time. And then obviously the actual media files are all pulled out of S3. So the content is, the media content, I should say, is never processed. It's just simply sitting on an object store like S3 or any other storage system for that matter, and is simply referenced by a playlist that's being generated dynamically in a Lambda execution environment. So the next steps for this project are release CloudFormation as open source AWS solution. I do have the CloudFormation stuff here. I was going to run through it, but I don't think I have time, and it's probably not that relevant right now. Implementing live sources, so you can do that already, but we can't do it through the front end or the API, so having the ability to insert an actual real live source rather than a VOD clip. Implement common key DRM schemes, so the ability to encrypt it and then have it served by a DRM license key server. That would be Fairplay, PlayReady, and Widevine, and then also build in support to generate an MPEG dash playlist as well as playlist. So the CloudFormation stuff, that has to go through our legal review to make sure that it's not using any third-party libraries that don't have the correct licensing terms to be used in such a way. Once that's done, it will be released as an AWS solution, which allows you to essentially deploy the CloudFormation template in your own AWS account. That will allow you to edit it, modify, pretty much do whatever you like with it, and you will only pay for the underlying resources it uses. And of course, you can turn it on, turn it off at any point in time, no commitments, you only pay for what you use. So with that, I'd like to thank everyone for their attention, and if you've got any questions, there is a booth in there where I'll be, otherwise I'll be here at any point. Yes?
If you have a great antenna in someplace in Australia, how many live channels are on the air?
In the traditional DVB-T sense?
If it's a traditional broadcast.
Yes. So each commercial broadcaster has 4 or 5 channels available, and there's 4 commercial broadcasters and 1, so it's about 20, 25 channels happening at once. Yes, so I mean, you could essentially replicate your entire broadcast system if it was just thematic VOD in the first place by using something like this, if you are only streaming.
A lot of those multicasts are essentially VOD playlists.
Yes, yes, most of the time. There's of course news and sports and things like that that are actually live, but those are generally on the tier 1 channels. So as you go down the tiers and the audiences drop off, they don't really include live programming on those channels. So there'll be like a fishing channel, and it's just got fishing shows 24/7. Yes?
What did you use to generate manifests in Lambda?
Oh, just a text, just generate, because it's essentially XML. So the playlist file is just text. You can just print out lines of text, and then it just gets returned.
Like a Node app or something?
Yes, it's all Node.js. Yes. Yes?
Yeah, about the playlist, you said that they were being dynamically generated by the Lambda.
Yes.
How does that interact with the scheduling, and what is the user interface for those wanting to schedule things or insert things that are not contrary to what's already scheduled?
Yeah, so the first interface I showed was when I auto-scheduled a whole bunch of stuff. That basically defines a schedule. And then when a user makes a request for that channel number in their playlist path, then it will look up that schedule that's already defined. So the user themselves don't define their own schedule. That's done by a content team. And the content team can define potentially thousands of channels, 1 per user based on some AI personalization, but the user themselves simply watches TV. They don't define what they watch. Yes? Yeah, as long as it's a media file, like an MP3 file that's already segmented for HLS, then yes, essentially. Yeah, it sort of assumes that the source content is HLS packaged already. Yes?
How do you trigger a client to forward buffer?
There's a tag inside HLS called start, EXTX start, and you just put in a negative value and you say start 60 seconds, like 60 seconds ago, and then it will automatically buffer the content that's in the playlist.
You put an offset, an EXT offset value, or just a start value?
That is an offset value. Yeah. If we can chat later, you'll see it in the playlist. You'll see a tag that basically says EXTX start offset or something like that. And basically it says from this point in the live edge, go back 60 seconds. Any other questions or no? All good? Okay, thank you very much.